Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. So in today's lesson, we want to look at finding derivatives of trigonometric inverse functions using trigonometric substitution method. Now, this is not a method that we've already into, but we will do that in subsequent lesson. That is from example number 21 upward. We're going to treat trigonometric substitution method in depth. But like we saw in question 13, we introduced it. We just want to solve this problem as well. This problem was solved. It was solved in question 5. So we solved this problem in question 5 or example 5. So we want to use now the substitution method to solve this same problem so that you know which one of them to use, which method is best for you. So cot inverse of square root of 1 of x squared minus 1. Now, so the first thing that should run to your mind, what are some of the identities of cot that we know that resembles this expression? So we know that there is a fundamental identity, that is the Pythagorean identity, which is cos square theta plus sine square theta equals to 1. Now, cot is defined. So cot of an angle is defined as cos of that angle all over sine of that angle, which we call the quotient identity. So now, since we need sine in the denominator, we can divide every term by sine square theta, and sine square theta. So cot over sine is cot plus this is 1, and then this is 1 all over cosecant. Let's say 1 all over sine square theta, which is cosecant or CSC square theta. So we want to solve for this cot. What is cot? So if we send this 1 across, cot square theta now becomes cosecant square theta minus 1. So we take the square root on both sides. We will have cot of theta equals the square root of cosecant square theta minus 1. So, but what is this cosecant square theta? So you see that this cosecant of theta could possibly represent our x. So now we will use the substitution, thereby saying let x equals to CSC of theta. So we can solve for theta by taking cosecant inverse on both sides. Cosecant of x is equal to cosecant inverse of cosecant of theta. So cosecant inverse of x now is equal to theta. So now we do the substitution. So we have y equals to cot of the square root of, now x now becomes cosecant of theta. But since x is squared, so we square it minus 1. So this entire expression is just equal to what? We know that this whole thing is just cosecant cot of theta. Or we say, yes, so we have cot of theta. So y now equals to just theta. What is theta? So theta was cosecant inverse of x. So y prime now will give us, and what is the derivative of cosecant inverse of x? So cosecant inverse of x is just equal to 1 all over x square root of x square minus 1. So we have this to be minus. So this is it. So if you check example number 5, this is the same solution, or this is the same problem and the same answer that we got. So thanks all so much for watching, and see you in our next lesson. Thank you.